Hey, good evening everybody. Tonight I've got my 9.25 here over my left shoulder. The seeing is pretty good. I'm aligned to Saturn, and my plan tonight is to go through each of the 3 filters in the Astromania Planetary filter pack. It's a 3-pack that includes an ultraviolet filter, an infrared filter, and a CH4 filter. After each one of the captures, I'll just go ahead and in real time for you guys share the processed results so you can see what the results of each one of the filters looks like. And then at the end, I will show them all together so you can compare each of the filters. The interesting thing about the infrared filter in this pack is if you look at the spectrum that it allows through, it's anything greater than 650 nanometers of wavelength, which is really not infrared. That is kind of a red filter. In fact, if you look at what it passes for wavelengths of light, it is the exact same as a red number 25 Celestron filter. So I will show you the infrared filter from Astromania, but I've also got a ZWO infrared filter that is 850 nanometers of wavelength and above. So that is a true near infrared filter. I think I'm going to start with that infrared filter, then we're going to go ultraviolet, and then we'll finish with the CH4, which is I think it's the coolest filter. To be honest with you, it's why I got the 3-pack. It was the only way I could get the CH4 filter at a reasonable price. So that's the order we'll go through them. Let's start with the Astromania infrared. As we get going here, I'll tell you my screen capture and PC camera failed to record after just a few minutes of capturing. So I have 2 hours of this for my screen capture and 2 hours of this for my PC camera. That was pretty frustrating, but it's not a big deal because I have the direct captures from my astrophotography camera, and this lets me use my fancy streamer mic here anyway. Before I go into the infrared filters, I did do just one capture here with full color with the UV IR cut filter that I always have on my camera. It says it's just a IR cut, but it does cut both. I'm really not convinced yet that this is better than no filter at all, but like I've said before in my videos, I always do this just in case there's some marginal difference. Here's the final processed image. It's the classic tannish looking Saturn that you can expect when you just capture in natural color. Now on to the infrared filters, and for all of those filters coming up, I'm just going to be displaying these, and I captured them in black and white because there's no infrared or ultraviolet color that can be discerned by us as humans. So infrared is the color, and if I shared it in true infrared, you wouldn't be able to see anything. This is the Astromania infrared filter, which, like I said before, is really just a red filter. You might think, well, it is passing the infrared band, but the problem is the camera's response is so much more sensitive to that red frequency that the fact that it's passing the infrared signal hardly makes a difference to the final image. And in this final image, really the main difference created by the filter is a slight darkening of the South Pole, which we'll talk about more on the next filter, which is the ZWO IR filter, which is the true infrared filter. Here's a quick live view of that capture. Going right to the final image here, you can see that the South Pole almost completely disappears. And so the theory here is that the polar vortex storm on the South Pole stirs up some aerosols that block some of those infrared frequencies coming from lower down in the clouds. This filter also increases the contrast nicely between that light central band and the north and south darker regions. And you can see the difference here next to the Astromania infrared filter in those contrasts. At midnight, I heard cowboy boots walking up behind me on the sidewalk. And so you can see here, I quickly turn on my outside home security cameras just in case I disappear. Somebody will have some great footage of the abduction. But it ended up being my new neighbor, and he decided to introduce himself at midnight. I guess there's no time like the present. After that, I decided to quickly try an orange filter, and really the whole purpose for that was in reading the descriptions of all of the colored filters on the Celestron information. Orange looked kind of intriguing. They described it as improved structure of Saturnian bands and highlights blue polar regions. And so in the final image here, I'm not sure that it did any of that, but it did create a really nice crisp image that I might go back to on future nights. Now for the next one, I knew I was up for a challenge. That's the ultraviolet filter. And I say that I knew that because Astromania states that this filter catches light or passes light between 300 and 400 nanometers, and my camera doesn't even advertise a capability to capture light below 400 nanometers. But you do see the blue curve doesn't exactly go to 0 at 400, so I knew there would be at least some sensitivity down there. I ended up having to take really long exposures, 10 times longer than the other filters, and really too long for planetary photography. Even then, even at 100 milliseconds, you can see that it's really dark. And I didn't want to expand that 100 milliseconds out anymore, so I just fixed it in post-processing. And here you can see that, as far as I can tell, there's really no value to an ultraviolet filter on a dim object like Saturn. I've been told it can help bring out some details, or any details at all, in the clouds of Venus. I'll have to try that sometime, but I might need a more sensitive camera for that at the ultraviolet frequencies. Finally, the one we've been waiting for, the CH4 methane filter, the last of the filters in the Astromania 3-pack. This one's really cool because what it does is it filters out everything but 890 nanometer wavelengths, which is the wavelength that is absorbed by methane. So essentially anything with methane is invisible in this spectrum because methane doesn't reflect 890 nanometers. And as you can see here, that's exactly what it's doing. And again, we're at the edges of the camera's abilities, so I had to crank up the gain and the exposure. But in the end, it creates this really cool final image where the rocky rings become the showcase feature and the methane-containing atmosphere is almost invisible. And in this picture, I actually really turned up the exposure in post-processing just to get some indication that there was a planet there somewhere behind the rings. And the rings at this point really don't show any detail because they're edge on. So overexposing I didn't feel like was such a big deal. It's definitely a really cool way to look at Saturn, and I'm kind of interested to see how that changes over time as the tilt in Saturn's rings maybe exposes more of the rings themselves, and we can maybe see some details with the methane filter. Here are all 6 images in a mosaic, I guess, so you can kind of compare each one of them. I think my favorite is the orange just because of the crispness of it, and I kind of like the contrast there. The ZWO true infrared filter is also really nice with those contrasts. And I think, like I said, when the rings become more slanted, the CH4 is going to be really interesting too. Hopefully you guys found this as interesting as I did, or maybe just half as interesting, because I'm way too interested in this stuff. And hopefully you're inspired to try this yourself. And if you've got other filters that you've tried on Saturn that are even more interesting or offer a different view, let me know in the comments. I'm just as interested in learning from what you guys have to offer in the comments as anything you might have learned in this video. So thanks again for watching, and we'll see you next time.